Hello viewers, this is Ishan Akbar and welcome to my YouTube channel. Before starting the video, I would like to request please subscribe my channel and recommend it to your friends. In this lecture, we will study that how can we calculate the force acting on a retaining wall with multiple backfill soils. In the figures below, you can see that there are multiple soils acting as a backfill behind the soil. Let us say in this figure we can see that this is soil 1, this is soil 2, and this is soil 3. So here there are three soils which are acting as a backfill because the unit weights of these soils are different from each other and their friction angles are also different. So if a soil has a different friction angle and unit weight, so we can say that the soil will have a different pressure or different stress on the wall. So on this side, you can also see that we have two layers of soil, soil 1 and soil 2. So they basically will have different impact on the soil face, on the wall face. So basically, we are going to discuss this impact means how multiple types of backfill soils can impact the stress on the back face of the wall. So simply in this example, we have this is the wall and we have static condition mean there is no yielding in the wall. For static condition we will need k naught. For active conditions we usually need ka, and for passive condition we usually need kp. But here we are going to discuss the static condition. For static condition we have to determine the static force or overall force that is acting on the face of this wall which is connected with the backfills. So this is the soil type 1 and this is the soil type 2. For these soils the solution will not be the same like we have solved for one soil, that is unit weight of soil is this one, say 20, and friction angle of the soil is 30 degree and c prime is 0, and we have solved this for the wall. This was a simple case that we have a triangular distribution of load and we only find a single force in this case. But when the soils are multiple, then we need to determine or we need to consider the impact of all the soils. So basically, we will have to determine the effective stresses at different points. So first of all, we will indicate the points. Let us consider this is the point 1 from where the soil 1 is starting. This is the point where soil 1 and 2 are coinciding, and this is the point where the soil 2 is ending. So basically, we have 3 points: point number 1, point number 2, and point number 3. So we need to determine the stresses at all 3 points for these two soils. So at point 1, there is no surcharge or there is no load acting above this point. So we can say that stress, vertical stress at the static condition is equal to 0 at point 1, simply. But if we move in the downward direction and reach the point 2, then we can say that this soil 1 is causing a stress at this point 2. So simply we can say that vertical stress due to static loads at point 2 will be equal to how much this stress will be. This will be unit weight of the soil multiply with the height of the soil. So what is the unit weight of the first soil? That is 15 kilonewton per meter cube. And what is the height of the soil above this point? You have to consider the height above this point. So what is the height of the soil above this point? That is 2 meter. So we will get the answer of 30 kilonewton per meter square. In the same way, you will calculate the stress at this point, third point. You will move in the downward direction and you will see that how much pressure is acting on this point from the soil surface. So what will be effective stress at point 3, vertical effective stress at point 3? So simply we can say here as gamma 1 H1 because this is gamma 1, this is gamma 2, and this is H1 for first soil and this is H2 for second soil. You can repeat or you can adopt, you can revise this procedure for multiple types of layers. At third point, the effective stress will be gamma 1 H1 plus gamma 2 H2. What is gamma 1? That is 15, H1 is 2, gamma 2 is 20, and H2 is also 2. So it will be 70 kilonewtons per meter square. So the first step in solving the retaining wall with multiple backfills is to determine the vertical stress. So the next step, we can say that this is step one. If you will adopt this problem as a procedure, as a stepwise problem, then you will be able to easily understand or easily perform any calculation about these problems. So what will be step two? Step two is basically finding the K naught. Because we have two soils, so we will determine the two values of K naught. Simply we can say that K naught 1 and K naught 2. So what will be K naught? Because there is no OCR value, so we'll consider that OCR is 1 over consolidation ratio. For normally consolidated soil, value of K naught is equal to 1 minus sine phi dash. 1 minus sine and phi dash here for the soil 1 is 30 degree. So when we calculate this, it will be equal to 0.5. And in the same way, we will determine the K naught 2, that will be also 1 minus sine phi dash. You can use here 1 and 2 for subscripts for soil 1 and soil 2. 1 minus sine 40 degree. So it will be 0.36. So in step 1, we have calculated the vertical effective stresses. In step 2, we have calculated the coefficient of lateral earth pressure at static condition, or static coefficient of lateral earth pressure. And the step 3. So the most important and most crucial part is the step 3. So beware while considering this, the most important. So my speed is a little bit slow so that you can get everything in this problem. So simply at point 1, what will be sigma dash h? Vertical is sigma prime V naught and horizontal is sigma prime H naught. So it will be 0 because V is 0. So at point 1, the will also be the 0 stress. So simply we can say that it is 0 stress. And now, what will be at point 2? We can see that point 2 is located in between two layers. So it is a borderline between soil 1 and soil 2. Mean at this point we will have impacts of soil 1 and soil 2 as well. So simply when we see a border between two layers, we mark it as 1 and 2. Just mark like this one, 1 and 2. This is 1 and this is 2. So basically when there is a soil interface, you have to evaluate two horizontal stresses. So simply at point 2, at interface between soils, two horizontal stresses are calculated. So it means that at every interaction between two layers, at every coinciding point between two layers, we will need to determine two horizontal stresses. There will be only one vertical stress at this point as we determine this one, but there will be two horizontal stresses because of this one vertical stress. So how we will calculate those stresses? So simply come to this point. It has a total stress of 30 kilonewton per meter square. This is known as the sigma dash V naught 2. We will have a horizontal stress sigma dash H naught 2 and sigma dash H naught 2 prime, just above and just below this point. So how will we calculate this sigma dash in upper layer in soil 1? Simply we can say that this is sigma dash H naught 2. This will be equal to K naught 1 times this value, because at this point there is only one vertical stress. We want to calculate two horizontal stresses. So how can we calculate these two horizontal stresses from one vertical stress? So we will have different values of k naught 1 and k naught 2. So simply, what is K naught 1? This is zero point 0.5. And what is sigma dash V naught? This is 30. So simply, we'll have 15 kilonewton per meter square as the horizontal stress. Mean at this point, just above the line, we have a stress of 15 kilonewton per square. And now, for the next or the just below point, this one, we will have K naught 2 times sigma dash V naught. So sigma V naught is same, but the only difference is the value of K naught. K naught 1 for the just above mean. If we are moving with three soils, soil 1, soil 2 and soil 3, and we are at this point, how we will calculate C. At this point, it will be sigma V1, sigma dash V naught 2, sigma dash V naught 3. At this point, we will have two stresses, sigma dash H naught 2 and sigma dash H naught 2 prime. At this point, we will have two stresses, sigma dash H naught 3 and sigma dash H naught 3 prime. So to calculate these two stresses, we will use the K naught values of these layers. This soil has K naught 1. So for this stress, we will use K naught 1. This layer is in, this point is in second soil. So we will, to calculate this value, we will use K naught H2. And at this point, we have two layers, this one and this one. So for calculation of this stress, we will have to use the K naught 2, and for calculation of this stress we will have to use the K naught 3. Simply from one vertical stress we can calculate two horizontal stresses based on the coefficient of lateral earth pressures of the soil. So both soils had different K naught values, so there will be two static pressures, mean here 0.5 and here it will be 0.36 into, this is same, and it will be 10.8 kilonewtons per meter square. So we have calculated the stresses at this point. There are two stresses. And now coming towards the third point, we will calculate the third horizontal stress, sigma dash H naught 3, that is equal to, see this point, there is no soil below. So this point is the bottom point of the soil 2. So we will use K naught 2. This has the value of coefficient as K naught 2 into sigma dash V naught 3. So we have calculated sigma dash V naught 3 here, that is 70. So we'll simply multiply 0.36 with 70. This will be equal to 25.2 kilo pascals or kilonewton per meter square. When we have determined these horizontal stresses, then our problem will be simple. So simply we will have to draw a diagram, a pressure distribution diagram along the wall. We will indicate 3 points or 3 lines on the intersection points, and we will draw the pressure diagram. See, remember that on this diagram we will draw sigma dash H naught values, not vertical stresses. So at this point, sigma dash H naught is 0, and just above this point, it was the sigma dash H naught 2. This is 15 kilonewton per meter square. So we have to move from 0 and we will move till 15. So this is 15 kilonewton per meter square. Next, sorry. And just below we have 10.8 kilonewton. Mean at the single point we have two stresses, 15 and 10.8. So we have to move back from 15 to 10.8 kilonewton per meter square. So we'll stop here and then go to next point. The next point is this one. At this point we have two stresses, so we have 2 points like this one. At this line we have 2 points, this one and this one, because this is the coinciding point or intersection point between two soils. So simply at third point the stress is 25.2, so we will move from this 10.8 to a value that is 25.2 kilonewtons per meter square. So it will be also a triangular distribution. So if we make the wall boundary as a line, so we can say that a proper distribution of soil is here. This is a line, this is a line, and here this is a point. So these lines have make some irregular shape. So basically we have to convert this into regular shapes. If we draw a vertical line there from this point, we'll have three regular figures: figure 1, figure 2, and figure 3. Figure 1 is a triangle, figure 2 is a rectangle, and figure 3 is also a triangle. So we will have to find the area of each figure: A1, A2, and A3. This will basically will be equal to the force P1, P2, and P3. The forces are indicated as like this one. So what will be the area of first figure? This is a triangle. It will have an area of 1 by 2 into base into height. What is base of this triangle? You can see here that this triangle has a base of this, and its value is from this point to this point the distance is 15, and from this point to this point the distance is 10.8. So basically this triangle has a whole length of this as a base, so it will be 15. And what is height of this triangle? This is 2 meters. Simply we will put 2, and the force of first figure is 15 kilonewton per meter, because this has a unit of meter and this is kilonewton per meter square. It will be cancelled with 1 meter, so kilonewton per meter. And for the second figure we will have a value of area as width into height. What is width of this rectangle? Rectangle has this figure or this area, it is 10.8 into what is the height of the rectangle, that is 2, it will be 21.6 kilonewton per meter. And for the same case we will find out the area for triangle 3. It is 1 by 2 into what is the base. See here, this triangle covers this much area, so its base starts from here and ends here. So total value from this point to this point is 25.2, but from this point to this point the value is 10.8. So to get the base of this triangle we have to subtract 10.8 from 25.2. So we'll write 25.2 minus 10.8 into what is height of this triangle, again 2 meters. So the force at third force will be equal to 14.4 kilonewton per meter. So we have got three forces. So if we add these three forces together, we will calculate the total force acting on the wall: P1 plus P2 plus P3. So if we add all three forces, they comes to be 51 kilonewton. So the total force acting due to these three diagrams or acting due to these two soils is 51 kilonewton per meter length of the soil. Now we have to determine the location. So location can simply be determined. We will consider this point as the reference. So if this point is considered as reference, I will erase this and will draw again. Our diagram will be like this figure and this figure. Its force, because a triangle force acts at one third from the base and rectangle force acts at half from the base. So we have two triangles. What will be distance from here to here? Because it has a height of 2 meter, so it will be 2 by 3 from the base. This is base of the triangle, 0.667 meters. So from the bottom of the wall, this point is considered as reference. So from bottom of the wall, it will be 2 meters plus 0.667, this one. So moment of first figure is 2 plus 0.667 meters. It will be 2.667 meters. For second figure, this is rectangular. So from this point, it will be half of the whole length of the rectangle. So total height is 2, and if we divide it by 2, it will be 1 meter, and m3 will be equal to this height. This will be h by 3. So h here is 2. So 2 meter by 3 is equal to 0.667 meters. So we have moment arms of all the forces, and we have values of all the forces. To calculate the location of that force, that total force, we will calculate z prime, that is p1 m1 plus p2 m2 plus p3 m3 divided by the total force sum, which we got like 51. So if we multiply, P1 is equal to 15. So 15 times M1. M1 is 2.667 plus M2 is 10.8. Oh, sorry, M2 is 21.6 and its moment arm is 1, while P3 is 14.4 and its moment arm is 0.667 meters, and the summation of all the forces is 51. So the Z prime will be equal to 1.4 meters. So what does it mean? The P is 51. So we can say that the total force acting on the wall due to these two soils is 51 kilonewton per meter, and it is acting at a distance of 1.4 meters from the base. So simply we can say that 1.4 meter is less than 2 meter. So from we will move from this point, which is reference point, to till a height of 1.4 meter, 1.4 meter, and we call this P as 51 kilonewton per meter, and its distance from the base will be equal to 1.4 meter. So basically, this is how we can solve a retaining wall. We can find out the thrust on the retaining wall due to multiple backfills. Thank you very much. See you with a new topic in the next video. Till then, take care. Allah Hafiz.